Hey, it's Mrs. Marquette. Today we're doing 7.4, which is inverse relations, specifically of linear functions. Today we're going to be doing a lot of stuff with relations and finding the inverse, but to do all of that, we need to remember some algebra skills, and specifically solving equations that have more than one variable. So we're going to do this warm up together. It says solve for y in each of the following equations. Remember that solving for y means getting y by itself, or I want each of these 1 through 4 to have y equals something. So on number 1, I'm going to use some PEMDAS backwards to get y by itself. Right now I have 3 times y, so to get y by itself, I will divide by 3 on both sides. And I'll have y by itself equals 6 divided by 3 is 2, and x. So the first one, not too hard. I just have one step to get y by itself. Number 2, I have 2y equals 4x plus 2. Again, I have something times y. So to undo that 2, I divide by 2 on both sides. Now the special thing, or the thing to remember about that right side, is I'm dividing the entire side by 2. So I have to divide 2 or 4x by 2, so I get 2x, and then also 2 by 2 and get 1. So you got to think about this as like 4x over 2 plus 2 over 2, and then simplify. Numbers 3 and 4 have a little bit more to do because it's not just dividing. This time if I do PEMDAS backwards, y is added to 3x, and this is a positive 3x. So to get y by itself, I need to do the opposite of adding, which is subtracting. So I get y is equal to negative 3x plus 6. Or you could have said 6 minus 3x, but typically y equals mx plus b form, or descending order, I want to have the x term first and then the constant. So y equals negative 3x plus 6. And finally, 2x plus 6y equals 6. I have a term added, and I also have a term multiplied. So you got to remember which order to do this in. I go PEMDAS backwards, so I subtract 2x first. Again, those aren't like terms on the right, so I get 6y equals negative 2x plus 6. This is a positive 6. And then I'm looking, and 6 is still multiplied by y, so I will undo multiplication with division. And y is equal to negative 2 over 6 is negative 1 over 3x, plus 6 over 6 is just 1. So again, I can think about this as negative 2 over 6 and 6 over 6, and then simplify from there. We are going to be doing a lot of that algebra stuff today during the lesson. So if this isn't making sense to you, maybe just go back and do a few more of these types of problems. But otherwise, I want to actually talk about what an inverse is, or an inverse relationship. So when we think about inverses, we sometimes think about two things that are opposites, or we can think in math things that undo each other. So if I think about adding a number to an original number, so if I say like 2 plus 5, if I want to get back to 2, I have to subtract 5. So 2 plus 5 is 7. To get back to 2, I subtract 5. So adding and subtracting, those are inverse relationships, or inverse operations. Then multiplying, if I take 2, excuse me, and I multiply by 5, I get 10. To get back to 2, I have to divide. So to undo multiplication, I use division. So those are inverse operations. The two new ones from the last couple of chapters are squaring and raising to any power. So if I square a number, so like 3 squared is 9, to get back to 3, I'm going to take a square root because the square root of 9 is 3. So those are also inverse relationships. That's why when we solve to get rid of a square, we use a square root. And if I'm raising to any power, like a third power, a fourth power, etc., 3 cubed is 27. To get back to 3, I have to take a cube root. So those inverse relationships are going to be really important today. But we're going to start by talking about a relation. So we learned back in chapter 2 that a relation is a mapping of input values to output values. That means if I am talking about like my height versus my wingspan. If I say that my height is 64 inches and my wingspan is 68 inches, then my input is 64, and what comes out of that is 68. So depending on my height, I'm going to have a different wingspan. So the taller I am, the larger the wingspan. So input is height, output is wingspan. So if I look at an inverse relationship, the inverse relationship maps the values back to their original. So here's like my original relationship. For each of these, I have an x value and a y value. So my -2 maps to 4, meaning if I give you -2, you tell me, okay, the output is 4. If I give you 1, the output is -2. If I give you 0, the output is 0, etc. I can actually graph this relation. So I graph -2, 4, -1, 2, 0, 0, 1, -2, and 2, -4. And I'm not actually going to connect those with a line because I'm only given the points. I'm not actually told to graph the line itself or the points in between. But now the inverse relation, I need to kind of do the opposite or go back to the original. So I'm looking, this time instead of 2 or -2 going to 4, 4 is going to go back to 2. So it's like going in the opposite direction. -2 is going to go back to 1 instead of 1 going to -2. 0 goes to 0, 2 goes to -1. But notice all we've done is we've taken all of the x's and all of the y's and we've just switched them. Okay, so I want you to actually write that down. What we're doing for inverse relationships and what we'll do all day is we're going to switch x and y. Okay, so we can actually graph that as well. So for -2, this time the x value is 4, the y value is -2. Then I have the x value of 2 and the y value of -1, 0, 0, -2, 1, and -4 and 2. So those are the original relation and the inverse relation. Again, we're talking about opposites, so in this case it's switching x and y. What we're going to do next is actually use algebra to find the inverse of a line. So to do that, I'm going to switch the roles of x and y and solve for y. This is actually given to you on your guide in 4 nice steps. The first step is that I want to switch f of x for y. In this first problem, that doesn't really apply because I already have a y, so check. That's just going to make it easier for me to deal with because we're used to talking in terms of y. Number 2 is that we're going to switch the roles of x and y. This one we can actually do. So I have y and x, and I'm just going to switch where they are in the equation. So that will mean x equals 2y minus 4. That step is not too hard, but it's essential. You can't forget that one. Number 3 is that I want to solve for y. So I've got y right here. This is why we did that practice, because I have to actually solve this equation, get y by itself. So I add 4 to both sides, and I get x plus 4 equals 2 times y. And then since 2 is multiplied by y, I'll divide both sides by 2, and I get y equals 1/2 x plus 2, because this is 1x over 2, and then 4 over 2 is 2. The last step says that I want to rewrite in proper notation. Rewriting in proper notation, in this case, I don't really have to change anything. You might be used to having a y on the left side and then 1/2 x plus 2, because that's how we usually see our lines, as y equals mx plus b. So you can certainly do that. But when you start with a y, there's not really much you need to do for switching f of x for y and then rewriting. We are really just doing those 2 middle terms. We're going to get to notation in just a problem or 2. But let's try this again. Number 2. First step is rewrite f of x for y. Already done. We have a y. Step 2 is switch x and y. So x equals -3y plus 6. Step 3 is solve for y. Subtract 6 on both sides. Again, these are not like terms. I have x minus 6 and then negative 3y. I have negative 3 times y, so I'll divide by negative 3. And this time I'm going to actually write y on the left side, just because I can write an equal sign either side. I can do it in either order. Then I can divide x over negative 3, which is 1/3 x with a negative, plus 2, because negative 6 divided by negative 3 is 2. And that is my inverse. What you'll notice is in this original equation, I had negative 3 times x, and then multiplying by a fraction is really like dividing, so that's an inverse operation. And then I had an adding 6. That's where this negative comes from, so negatives and positives being opposite of one another. So now you've really done the math, the algebra behind all of this. I want to talk briefly about notation. If you look at number 1 here, and if I asked you, like, what is y? So if I asked you to just tell me what y is equal to, we would really have two options. We'd have the option of y equals 2x plus 4, or we'd have y equals 1/2 x plus 2. It's kind of like if you are on a soccer team and you and another player have the same name. So if you've got like 2 Joes on your team, you have to figure out a way to distinguish the two. Because otherwise, if your coach is yelling at you from the sideline, they're going to have both of you looking at him when he only means one of you. So maybe you go, one of you is Joe and one of you is Jay. Or one of you is Joseph and one of you is Joe. Or one of you, has a different nickname. That's kind of what we are going to deal with this inverse notation. Remember that f of x is just another name for y, and we give it that fancy name because we want to distinguish between all of the other y's out there, so there aren't like multiple Joes on the same team. So if we have f of x, so we're distinguishing a particular function, we're going to talk about f inverse of x. That's just the notation for inverse. So we don't read that as f negative 1x, we read that as f inverse of x. But this inverse notation just means, hey, this inverse is related to the same f, okay? So instead of having y and y, I'll have f and f inverse. So for numbers 3 through 6, I'm going to do the exact same process as I did for numbers 1 and 2, but I'm just going to change my notation. So here, number 3, my first step, we were told to switch y for f of x. This time we can actually do that. So I'll have y equals 2x minus 4. So that's step 1. Step 2 is I want to switch x and y. So that's x equals 2y minus 4. Check. 3 is solve for y. So I'll add 4 to both sides. X plus 4 equals 2y. Divide by 2 on both sides. And y is equal to 1/2 x plus 2. This is actually the exact same algebra as we did above. So if you fell behind on that one, look back at your work from number 1. But the last step here is that we want to rewrite in proper notation. In this case, we have f of x. So what did we find? We found the inverse. So f inverse of x is 1/2 x plus 2. So again, really that last step, we didn't do any math, we didn't do any algebra, we just renamed it. It's saying like, okay, we've got 2 Joes, I'm going to call you J. Same process for this one. I'm going to first change f of x for y, so y equals 1/3 x minus 1. Then I'll switch x and y. X is 1/3 y minus 1. Fractions sometimes give us trouble with solving, so we'll pay attention here to that fraction. I have x plus 1 is equal to 1/3 y, and really I want to get rid of the 1/3. I want to get y by itself. So to get rid of fraction, I can multiply by the reciprocal. So the reciprocal of 1/3 is 3 over 1. So I'm going to multiply both sides by 3. I want you to notice that I put these parentheses because that 3 has to multiply to the whole side. So this becomes y equals 3 times x plus 1. Or if I distribute, y equals 3x plus 3. So that's all of the math again. Now I've just got to name it. What did I find? I found the inverse. The original was f, so I'll call this f inverse of x equals 3x plus 3. If you want to try numbers 5 and 6, why don't you pause the video, try them, and then go ahead and check your work. I'm just going to keep going through. So number 5, y equals 6x plus 3. So we're switching y for f of x. Switch x and y, and then solve for y. So subtract 3 on both sides. X minus 3 equals 6y. Divide by 6 on both sides, and we get y equals 1/6 x minus 1/2. Careful there, this is x over 6 minus 3 over 6. X over 6 is just 1 over 6 times x, and then 3 over 6 I can reduce that fraction. So then final step, rewrite in proper notation. 1/6 x minus 1/2 is the inverse of x. Number 6, same process. Y is negative 2/3 x plus 6. Switch x and y. X is negative 2/3 x plus 6. Y plus 6. Okay, then we solve for y. Subtract 6 on both sides. X minus 6 is negative 2/3 y. And again, the fraction can sometimes get us, so be careful. I want to get rid of my negative 2/3. So what is the reciprocal of negative 2/3? I've got to flip, so it'll be 3 over 2. And since the original is negative, the reciprocal is also negative. So negative 3/2 on both sides. So I get 6 over 6 is 1. So y is negative 3/2 x plus negative 3/2 times negative 6 over 1. Y is negative 3/2 x. And then multiplying those two fractions, we multiply across the top and get 18. Multiply across the bottom and get 2. 18 divided by 2 is 9. So final answer, F inverse is negative 3/2 x plus 9. If that fraction multiplication didn't quite make sense to you, go ahead and do a little side work one more time. Make sure that that makes sense. So that is finding inverses. We've always got those 4 steps. Take f of x, change it out for y, switch x and y, solve for y, and then rename it. You're going to go through that same process every time when you're looking for the inverse of a linear function. The last thing that we're going to do today is talk about the graphs of inverses. So as a little bit of review, we're going to draw or sketch the graph of f of x and g of x. Right off the bat here, I'm going to tell you that these are inverses. So what we're going to look for is what relationship do they have. So f of x is 2x minus 4. This is y equals mx plus b. So our b is 4, or negative 4. So this is the point 0, negative 4. And then our m is 2 over 1. So I'll go to 0, negative 4, and then up 2 over 1, and draw my line. Okay, I might even label these points 0, negative 4, and this is the point 1, comma, negative 2. Okay, then I'm going to draw g of x. So this is y equals mx plus b. So b is 2, so I have the point 0, 2. And then I have m equal to 1 over 2. So 0, 2 is right here, and then I go up 1 over 2, And I want to know what relationship do these two lines have. So I want you to notice this. If I drew the line right here, y equals x, so like corner to corner, if I folded this graph from the top left corner to the top or to the bottom right corner, the blue graph would actually lie right on top of the purple graph. So I could kind of like fold that in half. I can also notice a couple things. Negative or 1 comma negative 2 is on this graph, and the point negative 2 comma 1 is on my blue graph. The point 0 negative 4 is on my purple graph, and negative 4 0 is on my blue graph. Remember that inverses talk about switching x and y. So I can tell if two graphs are inverses if their x and y values are switched, and if I could take one corner and fold it to the other. So top left to bottom right over that line, y equals x. So that's this red line right here. So let's check that with a couple functions. I have, number one, two functions, the blue function and the red function, and I have this line y equals x. So if I think about folding the graph on this line, so like top left corner to bottom right corner, I can see that the blue graph would lie on top of the red graph. So this is actually an example of inverses. So I'm going to say yes, these two are inverses. They actually gave us this hint, f of x is y, and y equals f inverse of x. Number two, we could also fold our graph, but I want you to be careful. We're always going over this line, y equals x. Okay, so if I actually folded left corner to bottom right corner, I wouldn't actually have the pink graph lying on top of the blue graph. So this is a no, even though it is symmetric, it's symmetric over the wrong line. So it's symmetric over this line right here. And then number three, this time I do have the line y equals x. If I folded from top left corner to bottom right corner, my blue graph would lie on top of my red graph. So this is yes, I do have inverses. So you might be asked on a quiz or on a test, like, can you identify inverses? You're looking for points where x and y are switched, and you're also looking, can I fold that graph over the line y equals x? If you're asked to draw the inverse, this might look a little daunting. It's not just a plain line. But I do see that I have all of these points. Okay, so if I actually list the points, I've got 4, 4, 0, 3, negative 1, 1, negative 3, 0, negative 4, negative 2. And I know that for inverses, I have to switch x and y. So what I'm going to do is I'm literally just going to take each point and switch their x and y value. So this will be 4, 4. 0, 3 will become 3, 0. Negative 1, 1 is 1, negative 1. Negative 3, 0 is 0, negative 3. And negative 4, negative 2 is negative 2, negative 4. Notice I didn't change the signs, I only changed the order of x and y. So I've got 4, 4 actually is in the same spot. 3, 0 is right here. 1, negative 1 is right here. 0, negative 3. And negative 2, negative 4. And then I can connect those points. And if I actually thought about folding over the line y equals x, my black graph would lie right on top of that purple graph. But think about if I had missed one point and instead I had a graph that looked like this, I could tell that my graph was off because I wouldn't have the graph being symmetric over y equals x. So I've got to have every single one of those points to make the function an inverse. So that's a lot on inverses. You have to know for a quiz, for a test, how to find the inverse of a function given an equation, given a table, or actually given a graph.